My name is Forsten. I'm from Fairbanks, Alaska. I work with the Cold Climate Housing Research Center in Fairbanks, and I own a construction company and a consulting company. I kind of have this quest about building zero-energy houses, basically in Fairbanks, Alaska, in 14,000 heating degree day climate. So some of us, I guess, are not so smart. But how many people in here have built a passive house? I want to see some hands. Was it a challenge? Yes? So if I'm saying, passive house is way up there, would you agree? Yeah? Now we want to talk about beyond passive house. What is that supposed to mean? Any climbers in here? Anybody climbing mountains? Too? What happens when you get to the top of a big mountain? This is Denali in Alaska.
You look for a bigger one.
Exactly. I'm really sorry to break the news to everybody about this, but you're going to do the first, and you're like, oh my God, that was hard. But you're going to stand on the top, and you're going to like, oh, but there's another one. And then you're going to go on the next one, you're going to look, and you're going to like, oh man, but there's really better things we can do here. And this is what this is all about. And I'm going to make your life a lot more complicated because I tried to talk about sustainability in our culture. And I think that is something we really need to do when we start building passive houses. Forget about the first three because they don't count. The first three passive houses you will build don't count. That's your third time to learn how to do this. But how do we become sustainable in an unsustainable world? How do we transform from where we used to be to where we are right now? How do we want to get these cities sustainable? So I'm very lucky. I live in one of the most beautiful places in the world. I lived around the world for many years in different countries. This is my home. It has one problem. In the wintertime, it's freaking cold. On the alley, on top, I've been almost killed several times. It's extremely cold, it's extremely volatile, so it's a very harsh climate. But however, people have lived in this climate for a long time, very sustainable. The problem is what? We have evolved into something much better, and evolution has come a long ways, but we're stuck here. And that's where we are right now. So where are we going? On this climb, on this big mountain, where in the world are we going? I have no answers about this, but I want to give you a couple of things to think about. We always talk about climate change, about, this is going to happen. Now, I live in the last frontier, and this is today. This is not tomorrow. This is what we already see. This is a village the research center is working with since 3 years to relocate these people. This is what happens to their village right now, today. It's completely eroding away, and that whole village of over 400 people is being completely evacuated. So we're not the last frontier anymore, we're the first frontier. You can imagine living in that house? The Bering Sea pounding away from that? But that's reality. This is what we see today. We have 184 villages in Alaska which are affected by climate change today. So let's not talk about tomorrow. We're here today. So we're out of time. We're really already out of time. And in my opinion, this is where we are right now. Okay, free fall. It's just a matter of time when we're going to hit the ground. So, reality check. If we take all of our fresh water on this planet, we put it in a little cube. This is how much usable water we have. If we put this in perspective, it's not a whole lot. If we take air, the whole atmosphere, we wrap it in a little cube, this is all we have. Is that a whole lot? It's not. So energy, I think, will be one of our main problems. Water will be one of our main problems. And air. Air is, I think, something we never really think about too much. It's like indoor air quality, like what's happening in here, the ppm level of all of us being in here. Anybody knows how many breaths a human takes a day? How many air we consume per day? Anybody knows this?
24,000.
Yes, 20,000 breaths, 35 pounds per day. That's a lot of stuff. And we think about water, but we never think about air. So business as usual. I live in a very cold climate. To stay warm, we turn up the heat. And that's what's really happening all over the place. And we all know this, being passive house builders. Building industry is really where all of our energy is consumed, where we really can make the biggest impact. And if you're looking at 0 and at 150, not just 100, this is where our grade elite homes are. This is where we want to be with passive homes. But my question is, why do we want to stop here after the three houses you guys have done? I want everybody to look at this, because there's no reason not to be there. So passive house, I agree, it is a huge target. It's like this scary climb. How am I going to get up there? But when you're going up, and when you've done a few, I want you to think about a few more things, about what makes, houses, buildings, really function in the bigger picture of things. We need to look at people, health, comfort, energy, costs, and then embodied energy. But the number one thing, in my opinion, to remember is people. And when you starting to think about all this, it becomes like a maze. It's like, oh. And that's where I'm saying it becomes more complicated. But I have a good friend who has a lot of experience with sustainability, and he can give us some help. It's about people. We build buildings about people, not about buildings. And we oftentimes get wrapped up behind the idea that we need to design something so that we get things. It's like I walk around here and everybody says, oh yeah, the bathroom last. Makes me feel great, but it's not what it is all about. It's about the people which we build this for. And my question is this: what makes us human? And what do we do in houses? We raise children. We raise our new generation, which will have to face all of these problems. So evolution, where are we coming from? Where are we right now? But that is something very important. And if you look at the passive house, in reality, this is what we built. We completely disconnect ourselves from the earth, from where we are coming from. And if we are not careful, this is the feeling we will create in these buildings. And this is not where people, families should live in. So it's not just about energy. It's not just about comfort. It's about more than that. And there is kids who will grow up in houses who will need to have the sense of being human. So, I think it's very important to put natural materials, some feel, some sense of where are we coming from in houses, to create positive energy, to create beauty inside, to have a connection between the inside and the outside, and to make us human. Utilize plants. I work a lot with living walls, with planters, hydrocultures, air purification, air humidification, positive energy. We can use them for water recycling, for basically biospheres, where we can create living buildings where we recycle all our water. Passive house builders should know this. On an average building, that's 20 million BTUs per year just to make hot water. What do we do with this hot water? Gone. Is that a lot of energy in a passive house, heating-wise? It is. How can we keep this in our conditioned space and not just dump it? And why don't we make a law that we can't install anything else other than dual flush toilets in this country? I don't get it. So let's look at embodied energy. There's embodied energy basically in manufacturing, the energy it takes to make materials, and then what am I missing once it's made? It needs to be transported. So, it takes a lot of energy to move a ship like that. We bring it from China, and then we build passive houses here. embodied energy, there's a lot of different components. Take a good look at this and this. This is where really a lot of the embodied energy is concrete. It's very, very much embodied energy, like right here. It's one of the research topics we're trying to come up with geopolymer, the research center right now for replacing regular concrete. Take a good look when you build passive houses, not on the first one. It's the first one you're busy enough just getting it done, but on the second and third one, what am I putting into this building? How much energy does it have before I even build it? And oftentimes, this curve here is embodied energy versus your standard house and whatever else. But on a passive house, this comes way down. And if this line crosses your other line, then you have messed up. You missed your goal, if you look at the big picture. Where are we consuming the most energy? Depending on climate, of course. Heating, for me, it's definitely heating in domestic hot water. Know where your loads are, and then always remember.
Can you put that slide back there, just for a moment? Thanks.
Sure.
Snap it. Thank you.
This is reality. You built this house, and somebody's going to live in that house, and they have no idea about your intentions on this. They will do whatever they want to do. So we need to plan for that. We need to make it as simple as possible so that the homeowner who has no idea about this can live properly in this house. To me, the challenges ahead of us are all in communities. This is a community on a little island called Sabunga in between Russia and Alaska. Does this look sustainable to you? Somebody? Does this look sustainable? Is this any different than where we are right now? It isn't. I've been to many of these villages and I'm like, oh my God, we're flying in all of this fuel, we're bringing in all of this stuff, but walk around this town and think about where all of our products are coming from. Here it's very obvious. In our daily lives it isn't. And that is, I think, something we really need to relearn. It's like the passive house especially. We're like, oh, Germany makes much better windows. So we're bringing them from Germany. Germany makes much better HLEs, we're bringing them from Germany. But in reality, how much embodied energy is this? And where is our community making money off this? If you're living in a small community, any dollar you spend in that community stays in this community. That will be our future. We are not going to be able to sustain it. So, I think we need to really look into our own little communities, our own little businesses to move forward. Confused enough? Once you start thinking about these big pictures, so let's look for some more answers. I don't believe technology will save us. I really don't think so. We're already so disconnected. Go out for dinner and look around. Everybody's looking at their smartphone. This is where we are already with that. That's not going to get us where we need to be more sustainable. We need to look more back into basics and simplicity. And I believe we better start loving the sun. I believe that we will transfer into solar community if we want to or not. This is my favorite slide. This is the problem. I live in Fairbanks, Alaska. I have 2 months of no sun at all. And my house works in solar. So if I can make that work in Fairbanks, somebody tell me why it doesn't work anywhere else. It's because of this guy. We haven't made money selling us solar. That's why we're saying it doesn't work. But in reality, that's the only energy source we have, which is always there. This is an annual base. Globally, right now, we're 50 terawatts consumption. Annually, this is what we get from the sun. We just need to harvest it, transform, and we can completely build a world on solar. So this is a house I built in 2009. my first attempt to zero energy. It is off-grid, powered by wind, photovoltaic, and annual heat storage with solar thermal collectors. I use annual heat storage because I have no sun for 2 months. That's really the main reason why I go on solar thermal also in my climate. It just makes sense. It would take about 18 kilowatt system for an average house to be at zero energy in Paris. Pencil that out. It's a factor for efficiency, solar thermal versus PV, and we can store for longer periods of time energy in form of hot water, in form of phase change energy, thermal energy. Remember, in cold climates, it's all about heat. Versus, what do we do with photovoltaic? If we're lucky, we have a grid and we can cheat. We put it in there and forget about it. I mean, that's really what happens. Just try to do that as a whole, and then it doesn't work anymore. So on an off-grid house, it's very simple. To get to zero energy, either you get there and you make enough, or you can store enough, or you can't. That's really the short answer. And here we have 12,000 gallons of thermal storage to get us basically 2 months to this time when we don't have anything. This is my personal house, which I finished in January of this year. I have 480 square feet of collection, no fossil fuel. There is no heating system besides annual heat storage and solar thermal. And like I said, I just finished this in January, but since February 5th, I haven't burned, I have a masonry heater for backup, but I have not burned any wood. I'm at 100% solar since February, basically, for all of my domestic hot water, for all of my heat needs. Not really a big deal here, but if you would be in Alaska right now, it would be a little bit different because it's colder. February we still have 20, 30 below. It's winter until May. Our winters are fairly long. So I produce all of my energy for this house with half a light bulb, with 48 watts. With 48 watts, I make all of my hot water for family, for showers, for whatever else, 100%. I can run the system in the summer for 3 days, turn it off for 6 weeks. So 3 days, 48 watts, and hot water for 6 weeks. Is that amazing? Is that something which makes sense?
How big a storage tank? How big a storage tank?
Go looking at it. So what am I doing is basically I place a big seasonal storage tank in the center of the building. Why is it an upright tank? Stratification. We in buildings, in residences, we need to make hot water. Like in my climate, if I look annually, hot water is really the bigger demand in a high efficient building or heating. So if I want to make hot water in a big container, if this thing would be sideways, it would be a lot more water. But on 5,000 gallons, basically, it's a tank in a tank design. So I have a big volume of water which has superheat. And inside, basically, through convection, is a stainless steel tank which is bolted in the top and produces domestic hot water. Water pressure from the water source just goes right in there, gets superheated basically by convection. I can run my 2 bathtubs wide open for over an hour before I lose domestic hot water at 120. You try to do that with a boiler, it's impossible. All of this stuff is built off shelf materials. I can write you a list right now. You go down Home Depot and buy most of the stuff. There's nothing to it. It took me about 5 years to get to this point. But now it's so simple, it's so affordable, it's a really good solution. So inside this tank, basically, this big tank is an old fuel tank. I bought it used for $1,000. Inside is a liner which I place. This is the stainless steel 40-gallon tank. This is preheating of the cold water. My water temperature is 30 degrees almost when it comes out of the ground, 34 degrees. And then this here is what I call the solar stratifier. This was my missing link for many years. In Europe, they do these houses with coils. Doing coils for these big tanks is about $24,000 in stainless steel. So it's unfeasible. This device here, what I call the solar stratifier, you can buy these pieces for about $800 in any pawn store. And it works just by physics. It's basically water, temperature, density. And I'm writing a report about this. Masonry heater. Anybody familiar with them? What's a masonry heater? What is a masonry heater?
It's a wood-fired appliance, but anyways, you can draw from the outside.
It's basically a masonry heater
You would store
was developed in the 1700th century in Europe when they ran out of wood. They cut all the wood down for building houses, ships, and firewood. So they figured out, oh, we have to do something to burn wood more efficiently. So masonry heaters are basically high efficient wood burning devices. But it's really, really old technology. It's a big firebox, lots of makeup air, and on both sides it has air scrubbing channels. When we burn a fire, it's at 1800 degrees, very hot, no emissions, and we store all of the energy in mats. What happens in a passive house if you put a wood stove in and you light a fire? What happens? You open the windows, the doors, you overheat. You know, in a passive house, you just don't have enough requirements. Here, you burn one fire, it stores it in the mass and radiates it out slowly, so you don't overheat. I burn in the wintertime about a quart of wood, roughly, and one fire lasts me for 2 days. Plus, it makes hot water, because it ties right into the same system. It basically ties into this tank right here, circulates through that, stores additional heat in the top of the tank to produce through convection hot water.
Is there an additional coil in the stainless steel tank?
There's 2 coils here in the fire box, one at the top. And then, of course, you can cook and bake in here.
And how's that connected?
Again, this is Fairbanks, Alaska. You know, in my lifetime, you wouldn't have to do this. I mean, if I wouldn't have 2 months with nothing, I wouldn't need it. I would be at 100% solar.
Thorsten?
Yeah.
Outside combustion air?
Makeup air, 6-inch makeup air with a cold shot right under the heater. Yeah, you gotta have makeup air for it. So, you know, I strongly believe we can build these living buildings today. We can build buildings which completely function by themselves. My personal goal right now is really to develop completely passive systems for ventilation, just through temperature differential, to minimize the load on the building to a level where we completely run passive on these buildings, even in extreme climates. And I think today we already can build these if we put our minds together, and it's the only way for me for the future. I don't see any other way. And where we really, really need to start is in schools. We need to start educating our children for what is ahead of us, all of the problems we will be faced with. And if you have any grief anywhere, anything going on in your community, try to push for a green living school, a passive house school, where kids can go to school and learn about renewable energies, so that they're growing up with something they can look forward to. This is, I think, why Europe is so far ahead of us. It's not because of energy costs, it's because of education. And you know, this is a wonderful school they built 10, 12 years ago in Germany. You know, kids who go in there, they have a much better understanding about renewable, about super insulation, all of these things. My 5-year-old can already explain everybody how our house works. Makes sense to her. So, you know, I've been on this quest for a long time now. And we have many, many things we can do if we put our minds together. And my question really is, what is our excuse? Why are we not doing it? What is our excuse? And that's, I think, something we need to ask ourselves every day. That's what I do every morning. What is my excuse of not pushing forward? Because remember, we're in free fall. It's serious. I see it every day. And you know, every one of you in this room, you can be this little seed you carry. Every project you will do can be this little pebble in the pond where we can make a difference. And we really can do that. If I see the impact I have been able to do with my little projects in my community, it's amazing. I had at least 5,000 people through my house order this year, and people are like, wow, this makes sense. They can touch it, they can feel it, and how do you argue against producing all of your energy with half of my home? Hard to argue. Questions?
What do you do for electricity?
Right now, I'm trying to develop this, but this is really experimental right now. I'm trying to develop a 5 kW generator basically to run solar thermal with the program on a temperature differential base. So that's basically what I'm working on. For our climate, photovoltaic is not the best answer. And for you know, projects I'm working on, we need different solutions for these remote villages.
Wind? Must be a lot of wind up there, no?
Not really where I'm at, but some areas, yeah. But you know, I need to be at zero energy on this building, which I haven't put up yet. I need about 5 kW to be at complete zero energy. Yeah.
Living in your house with your daughters and your wife, is there something after you moved in that they were happily surprised about, and is there something that they wished was a little bit different?
No, everybody's very, very happy. And the house has a lot of really positive energy. That is something, you know, which really amazes me to see how it affects people. You build these houses with lots of natural materials. I have lots of people through the last 3 projects which we've done, which are very similar. People walk in there and they're like commenting on it. Wow, this is positive. This is so positive. You feel happy. You know what? Feeling of ability.
To answer your question, I think what's our excuse? I've been thinking a lot about this. Is economics. I think economics are always the driving factor in this respect.
You know,
We had cheap energy for years, so there hasn't been an incentive in this country.
Let me interject this. I'm building this commercial building in Spring, which I already designed. It's a 25,000 square foot building, which will be at zero energy in my climate, with a payback of 4.8 years at today's fuel prices. You tell me, where are the economics?
Well, I'm going to explain it this way, if I may. You know, Passive House and energy thinking along those lines, zero energy, low energy, really, in my opinion, started in the 70s, and it started when we had the oil embargo. When people started to have lines and gas is going up in energy, that's going to be an economic factor. And I think about off-grid technologies in a world that is so connected that grids, you know, from a terrorist attack could be affected. What do you do if your grid is down? Well, if you're grid tied, you're not generating energy with all the solar power that you have on your panels. So I think about national security, I think about competitiveness from countries, and I think a lot of the future could be in developing countries, because they don't simply have the infrastructure. They don't have the grid technology, they don't have that. And countries that adopt such things, I think they're going to be economically competitive in the future. So I always go into economics in that respect.
We're not looking hard enough. That's my belief. We are hiding behind excuses. We're almost out of time. One more question, and then this time is up. You can find me. I'm around. Don't be afraid. Shy. I'll try to answer. Yep. One last question. Yep.
Fine. So, the solar thermal storage you're using, are you going to post that design?
Yeah.
It's gonna go
Yeah. No, a lot of people are like, you gotta get a patent on this, but I don't. You know, I want to make all of this available to everybody and provide you with material as to how you can replicate it. I mean, that was one of my main goals. This needs to be really replicatable. It needs to be affordable. Otherwise, it's pointless. But yeah, no, I look working on much better platforms to get this information out. Just bear with me, I'm trying to do too many things.
You guys have a website for cold climate?
Yeah, Cold Climate has a good web page, and most of my other research is up. This will be part of it. Thanks so much.